Welcome to FMSP Online Revision. This session is for OCR D1 and the topic that we're going to look at is graphical linear programming. So we'll start by having a look at the specifications. Now this actually forms part of specifications just titled linear programming, in which there are 4 sections, but we're just going to concentrate on the graphical bit. So we're going to look at just part A and part C. So in a separate session I'm going to do parts B and D, which cover the simplex. So let's just look at the 2 bits that we're going to look at today. So we're going to check that we can formulate in algebraic terms a real-world problem posed in words, including the identification of relevant variables, constraints and objective functions. And then in part C we're going to carry out a graphical solution for 2 variable problems, including cases where integer solutions are required. So let's have a look at the first question that we're going to do. Now, as I say, this question is quite long, it's very wordy. So it is important that when you're doing this that you read through the question and you try and pick out the important bits of information. So Maggie is a personal trainer, 12 clients who want to lose weight. She decides to put some of her clients on weight loss program X, some on program Y and the rest on program Z. Each problem involves strict diet. In addition, X and Y involve regular exercise at Maggie's gym, and the programs last for 1 month. Now it seems that X, Y are the ones that we're going to be interested in particular because they're going to use Maggie's gym. So in addition to the diet, clients on program X spend 30 minutes a day on a spin cycle, 10 minutes each day on a rower and 20 on free weights, and at the end of 1 month they expect to lose 9 kilograms more than a client just on a diet. And then we have clients on program Y. They spend 10 minutes on a spin cycle, 30 on free weights, they don't use the rower, and they expect to lose 6 kilograms more than a client on just the diet. Because of other clients who use Maggie's gym, the spin cycle is available for the weight loss clients for 180 minutes a day, so that's important. The rower for 40 minutes each day, and the 3 weights for 300 minutes each day. And only 1 client can use each piece of apparatus at any time. And their question then goes on. Maggie wants to decide how many clients to put on each program to maximize the total expected weight loss. She models the objective as follows. So remember that clients on program X were likely to lose 9 kilograms more and those on program Y 6 kilograms more. So we're asked, what do the variables X and Y represent? We've got to write down and simplify the constraints on values of X and Y for the availability of each piece of apparatus. Remember, we had the apparatus were the spin, the free weights and the rower. What other constraints and restrictions apply to the values of X and Y? So we'll look at that in a minute. And then part 4, we've got to use a graphical method to represent the feasible region. It says use graph paper, choose suitable scales so that we can clearly see the feasible region and hence determine how many clients should be put on each program. So let's see if we can break that down a little bit. I've abbreviated the question here at the beginning to try and pick out the bits of information that we need to answer this first question. So what do the variables X and Y represent? So you've got these 2 weight loss programs. So X must be the number of clients on program X and then Y similarly for program Y. And just make sure it's only one mark, but you need to write down it's the number of clients for each case. So I'll just tidy that up a bit. So that was the first thing. So remember, she was putting some clients on program X, some on program Y, and then program Z we haven't had so much information on, but that was what the other clients were going to use. In addition to the diet, clients on program X spend 30 minutes each day on the spin cycle, 10 on the rower and 20 on the free weights. And then you've got program Y, 10 on the spin cycle, 30 on the free weights, and they don't use the rower. And then we're given restrictions. We're told that the spin cycle is available for the weight loss clients for 180 minutes a day, the rower for 40, and the free weights for 300. So I've sort of underlined or tried to underline the important bits. So it says, write down and simplify the constraints on the values of X and Y from the availability of each piece of apparatus. So the spin, if we take the spin first of all, and then we've got the rower, so make sure you can identify each of the bits of apparatus, and then we've got the weights. So those are the three things that we're given information about. So let's just think about the spin cycle. So we've got X clients doing program X, and they can spend 30 minutes on the spin cycle. You've got Y programs doing Y clients doing program Y, and they can spend 10 minutes. So that's 30X plus 10Y, and you've only got 180 minutes, notice, so that has got to be less than 180. And if we divide through by 10, we get our first constraint. The rower, now clients doing program X spend 10 minutes on the rower, and we've got X of those. Program Y, they don't spend any time on the rower, but we've only got 40 minutes of rower, so that has to be less than or equal to 40, so that means that X has got to be less than or equal to 10. And then we come to the free weights. So any client doing program X spends 20 minutes, and any client doing program Y spends 30 minutes, and that has got to be less than or equal to 300. And again, if we divide through by 10, we get our three constraints. So there is 1 mark for each of those constraints. And the other question we're asked here is, what other constraints apply to the value of X and Y? So remember that X and Y were the number of clients. So you're unlikely to go to the gym and see a fraction of a client. So just bear in mind that X and Y must be non-negative. You don't get many negative clients either, and they must be integers. I'm putting non-negative as opposed to positive because of course it is possible that you would have naught. One of them could end up being 0, and you got 1 mark for that. It then said use a graphical method to represent the feasible region for Maggie's problem. You should use graph paper and choose scales so that the feasible region can be clearly seen. Hence determine how many clients should be put on each program. So just be careful when you're drawing these. I have drawn these out because it's easier to do it for this one. But X is equal to 4. Hopefully you would recognise here is this blue line. vertical line, we want x is less than or equal to 4, so I've shaded out the area which is greater than 4. So remember, when we're doing this, we shade out the area that we don't want. So I think that's probably about the first one we might draw. 2x plus 3y is equal to 30 is the line that we would want to draw. So again, just make sure that you take 2 points. I would normally take when x equals 0. You'll then get y is equal to 30, and when, sorry, y is equal to 10. If x is 0, 3y is 30 and y is 10, which we've got up here. And then if y is 0, then 2x will be equal to 30 and x is equal to 15, and we can't see that on our graph. And similarly up here, which is the red line, so if x is 0, y is equal to 18, so we can't see that, and if y is 0, x is equal to 6. Now you would have all that information on your graph, but do choose, as I say, suitable scales and make sure you can draw those. So this now is our feasible region in here. So again, just reminding you that we always shade out the area we don't want. So this is the feasible region. And what it says is we've got to determine how many clients should be put on each program. So you could use a profit line. You could draw a line representing 9x plus 6y and move it out and see which point seemed to give you the maximum. Or else we could do a tour of the vertices. So I'm going to do a tour of the vertices. So I'm going to start with the vertex 4, 0 here. So when x is 4 and y is 0, then our value is going to be 36. I'm then going to take this point, which is 4, 6. So when x is 4 and y is 6, that's going to be 36 plus 36, which is 72. I'm then going to look at this point. Now, I'm going to just approximate it at this stage, and we'll discuss it later. You could use simultaneous equations if you want to be exact about it, but I'm going to just work on the basis that it looks a bit like it's 3 point something. It's less than 3.5 because it's to the left of that, so I'm going to say about 3.4, and the y coordinate is going to be less than 8, but this is 7, so it seems more than 7.5, so I'm going to estimate it to be about 7.7, and we'll discuss that in a minute. And if I work out that value for 9 times 3.4 plus 6 times 7.7, I'm going to get 76.8. And then the last vertex is this one up here, which is 0, 10. I'm going to check that. And of course, if x is 0 and y is 10, then this will be 60. So this is the one that is looking like it would give us a solution. But of course, if you think about it, remember that x and y are the number of clients. And as I said before, we don't normally, we have to have a whole number of clients. So what we need to do now is we need to look at points which are close to this vertex. So we might look at this point, and we might look at this point. Well, we've already done that. That was 4, 6, that was 72, so we know that value. And we might look at this point. So I think it's just worth having a look at different points. You might take this point. So what I'm going to do is I'm going to just go on to the next slide to have a little look at that. So again, I'm suggesting we've got this one, which was 4, 6, which we said was 72. So remember, it was 9x plus 6y is what we're trying to maximize. This point here, which is 3, 8, we substitute in those. We get 3 9s are 27, and 6/8 are 48, so that will give us 75, so that is better. And as I say, I will just check this one because that's okay. X has got smaller but Y is bigger, so that would be 18. 2 9s are 18, 6 9s are 54, but that is definitely going to be smaller, isn't it? So 18 and 54 is 72 again. So the biggest one seems to be here. Okay, so that means it looks as though we should have 3 clients on program X and 8 clients on program Y. And that will make best use of our available equipment and the best weight loss for our clients. Now, there were 6 marks in total for this question. You did get a mark for getting the final accurate answer. You got a mark here for sort of this information, just checking integer values. And then going back to the previous slide, you will have got a mark for drawing the axes correctly and for showing the feasible region, and an accuracy mark for getting everything correct. So effectively there were 3 marks for getting your graph drawn correctly, and then there was a mark here. So 6 marks. So if we just talk about it again, 3 marks for the graph, 1 mark for this initial checking of the vertices, and then 1 mark for examining integer values near our vertex, and then 1 mark for the answer. So that is an example of a question where you've had to draw the graph. The other type of question that you might get is where they give you a graph and you have in this case to write down the inequalities that define the feasible region, and then perhaps do a little bit of work on the objective function. So we will have a look at this question. Just be aware that when you're doing this sort of question that you do need to be careful with the accuracy. So and it's difficult on this, but I have just put in a little bit of information about these points. So this point here is actually the 0.35. Now hopefully in your exam paper you'll see that more clearly. And the other point you might want is this point here, which is 4.2, 4.2. And again, you could read that off more accurately from your own graph when it's a bit bigger, I think. If you're ever in doubt, of course, you can use simultaneous equations. So that's what we're going to try and do now, is to write down the inequalities. So you're getting 3 marks for this. Don't ever forget to write out the 2 variables about x and y. So x is greater than or equal to 0. In this case, the y is greater than or equal to 0 is not particularly appropriate, but it often is. This is the line which is y equals x, and again just check it will go through the 0.22, it will go through the 0.33, and it will go through, as I said here, this which we need later, 4.2, 4.2. So y equals x is the line, and we want the area above it, so it's y is greater than or equal to x. So we now have this boundary, and we have this boundary, and we now have to find the third boundary. So we know that this point is 0.7, so we know the intercept with the y-axis. So we just need one other point on the line. Now that's why I've marked this point in for you, which is actually the 0.35. So the gradient of that line Now it's going to have negative gradient because it slopes in that direction. Is going to be 5 minus 7 over 3 minus 0, so it's actually going to be oh right, I didn't need to put that in, so it's minus 2 over 3. Sorry, I don't need that minus sign in because of the way I've subtracted them, but I was just wanting to remind you that it would have a negative gradient. So it's negative 2/3, and of course we know that intercept is 7, so it's going to be y, the gradient is minus 2/3 x, the intercept is 7, and again we want the area below the line, so it's y is less than or equal to minus 2/3 x plus 7. So these two together, there was 1 mark because they were fairly straightforward, and then you got a method and an accuracy mark for writing down these two. A little bit harder. So just be careful, but it's a bit of pure maths really, isn't it? And then we're asked to find the values of x at the optimal point. So we have, if we go back and just check on our graph, so we have this point 0, 0, and we have this point which is 4.2, 4.2, and then we have this point here which is 0, 7. So if we put those in, so that we have the vertices, and then we have our objective function x plus 6y, and the third vertex of course is really not appropriate in this case because it's just 0, so we had the vertex 0, 7 and the vertex 4.2, 4.2. So working out the value of that function, it's going to be 42 there, and it's going to be 4.2 plus 6 lots of 4.2, which is 29.4. So you can see that in this particular case, if we're wanting to find the maximum value, so we just need to write that down. So P is maximum when x equals 0, y equals 7, and the maximum value that P can actually take is 42. So don't forget to write the information down. The examiners don't want to go and look for it. So you get 1 mark for sort of checking these two results here, these two vertices, and then you got a mark for saying x equals 0 when y equals 7, and you got another mark for writing down the value of P to be 42. So I'm going to finish this session here and just remind you as always, lots of practice, that's always the best way of revising your maths.